Welcome to Master Mathematics in Minutes. Today's topic is the arithmetic progression. We'll start off by defining what an arithmetic progression is, and we'll then cover a couple of examples on how to describe an arithmetic progression. And we'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is an arithmetic progression? An arithmetic progression, or arithmetic sequence, is a sequence of numbers where there is a constant difference between consecutive terms. We'll have a look at this visually. Consider the following arithmetic progression. With a as the first term, a plus d as the second term, a plus 2d as the third term, and so on. So notice that the difference between consecutive terms is d, and we'll call that the common difference. And we'll label the first term as u1, the second term as u2, the third term as u3, and so on. And we'll call the first term u1 is equals to a. And the common difference is denoted as d. And the total number of terms in this progression is n. And n can be any number. It can be 5, it can be 10, it can be infinity. For a generic kth term, we have the formula uk is equals to a plus k minus 1 times d. So say if we're looking for the second term with k is equals to 2, and that gives us u2. And replacing k by 2, 2 minus 1 gives us 1, or 1d, and that matches that a plus d. Say if we're looking for the fifth term, we'll put in k as equals to 5, and that's u5. And replacing k by 5, 5 minus 1 gives us 4, or 4d, and that matches that a plus 4d. And because we've assumed that there are a total number of n terms, the final or last term, which is denoted as L, is equals to un, given that we have n number of terms, and we'll replace k by n. And that gives us a plus n minus 1 into d. So we've defined the arithmetic progression. And we'll have a look at a couple of examples now. So in the first example, we're asked to consider the following arithmetic progression. We have 2, 4, 6, 8, 10, and so on. And we're asked to find the first term, the common difference, as well as the total number of terms. So the first term in this case is 2, and so we have u1 equals to a equals to 2. And 2 plus 2 is 4, 4 plus 2 is 6, and 6 plus 2 is 8. And so the common difference is d is equals to 2. And by counting the number of terms, we have 1, 2, 3, 4, 5, 6, 7. And that gives us a total number of terms, n is equals to 7. In the second example, we're asked to consider the following arithmetic progression. We have 5, 8, 11, 14, 17, and so on. And we're asked to find the first term, common difference, and the total number of terms. The first term, in this case, is 5. And so we have u1 is equals to a is equals to 5. And 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. and so we have the common difference of d is equals to 3. And by counting the number of terms, we have n is equals to 8. So in the third example, we're asked to consider the following arithmetic progression: 7, 17, 27, and so on. The first term is 7 in this case. So we have u1 equals a equals to 7. And because 7 plus 10 is 17, 17 plus 10 is 27, and so on, we have the common difference as d is equals to 10. And there are a total of 5 terms in this progression, and so n is equals to 5. So in the fourth example, we're given an arithmetic progression: 100, 150, and 200. So the first term in this case is 100. And so we have u1 is equals to a is equals to 100. And because 100 plus 50 is 150, 150 plus 50 is 200. And the common difference d is equals to 50. And there are a total number of 3 terms in this progression. In the fifth example, we're given an arithmetic progression: 80, 90, 100 as the first 3 terms, and we're given the final term of 160. Notice that this is an incomplete progression because we're not given the terms in between. And we'll also find the first term, the common difference, the 6th term, as well as the total number of terms. So the first term in this case is 80. So we have u1 is equals to a is equals to 80. And because 80 plus 10 is 90, 90 plus 10 is 100, we have a common difference of d is equals to 10. And to find the 6th term, we'll use the generic kth term formula, where we have uk is equals to a plus k minus 1 into d. And we'll replace k by 6 because it's the 6th term that we're trying to find. And a is 80 as above, and k is 6 because it's the 6th term that we're looking for, and d is 10 as above. So simplifying that gives us 130. So despite having an incomplete sequence, we're able to find the 6th term, which is 130 in this case. And to find the total number of terms, we will equate the last or final term formula to 160 and solve for n. So we saw earlier that the final or last term is given by L is equals to un, and that's equals to a plus n minus 1 into d. And un, which is the last term, is 160 in this case. And a is 80 as before, and n is what we're trying to solve, and d is 10 as before. So 160 minus 80 is where we've brought the 80 to the left-hand side, and we've expanded the brackets to be 10n minus 10. And 160 minus 80, that gives us 80. And bringing the minus 10 to the left-hand side, that gives us plus 10. And we'll copy the 10n down. So 80 plus 10 is 90. And we'll copy the 10n down. And solving for n, that gives us n is equals to 9. So despite having an incomplete progression, we're able to solve for the number of terms in the progression, which is 9 in this case. So to summarize, an arithmetic progression is a sequence of numbers. We have the first term as a, the second term as a plus d, and the third term as a plus 2d. And there is a common difference of d between consecutive terms, and we'll call that the common difference. The first term is labeled as a, and we can also denote that as u1 is equals to a. And the common difference is known as d, and the total number of terms is n. So n can be 5, it can be 10, it can be infinity, or any other number. And the generic kth term formula is uk is equals a plus k minus 1 into d. And the final or last term is L is equals UN is equals A plus N minus 1 D. Thank you very much for watching. This is Master Mathematics in Minutes.